Good morning, everyone. My name is Catherine. I'm really thankful to the session chair, Ajit Ranade, sir. So I'll start my presentation. As already mentioned, the topic for my presentation is blue accounting. So in all the presentations that we've looked at now, one key factor that is kind of the dictating factor, which everybody is not sure of what exactly the value is what is the monetary advantage that a particular endeavor is going to give you, be it sediment management study, be it your underwater radiated noise management study, whichever endeavor that you undertake, if you are unsure about what is the advantage that it is going to give you, it will not it will not lead you to a satisfactory decision making system. So in that context, what at MRC we have the next step that we are taking up after we started the research on various other different sectors in ocean is understanding what the blue accounting process should be, because it's not an easy task, because you have unlike terrestrial ecosystem, most of the ecosystem related to your oceans is underwater, and which is not clearly visible, and even the stock and the flow in your oceans are not clearly understood or defined at this point of time. So when you don't do that, you don't even have proper data to back it up. So in that context, how do you take this particular endeavor forward? So that is what we have been trying to do. And in this particular project, the unique contribution, the unique aspects are going to be that we are going to be using three major capabilities, which is the underwater domain awareness capability, the blue accounting methodology that we are developing, and the modeling and simulation based marine spatial planning. So under this with this background, I will move on to the presentation. So starting off with why we are doing it, because we know that the ocean is productive. Because there have been exploratory research on what is available underwater. Even though we don't understand it completely, we know that there is a lot of potential for minerals, mining of minerals, or your livelihood development, for your food security. So yes, I just started off with the background. So we know that the ocean is productive but poorly accounted for. So within this context, we have a conventional account system which answers your key question about what kind of gain we are getting from different ecosystems, which is visible. For example, or the sector that is visible. For example, you have fisheries, you have tourism, you have shipping, you have aquaculture systems. So when you have what we have been doing till now in the conventional accounting system is to capture the economic flows only, without understanding the natural capital which is sustaining them. So what we are trying to do here, we are trying to make visible the degradation of the asset base or the exploitation of the asset base as such. And the blue accounting, what it makes is that it makes the ecological conditions and ecosystem services visible alongside your economic performance. Even if you're not able to bring out an additive image, but you are going to be accounting it, tracking it, and making it visible. So we are particularly why this is important for our system is that we have a lot of overlapping systems that are together in place, but in the tropical waters we have a high value system. One particular stock has a multiple range of ecosystem services and outputs which needs to be accounted for, and then at the same time it's a high velocity system, where the changes are there are extremities, there are dynamic changes which are the periodicity of changes is high. So in that scenario, our monsoon dynamics, our blue carbon ecosystem, our biodiversity, the livelihoods that are dependent, because we have a high population state. So the livelihood is going to be, the dependence is going to be high. The climate shocks, the governance issues with regards to different departments managing different aspects, and the lack of data. So all of this creates a very a complex system in our tropical waters, and to understand that, or to untangle the whole system, to as much extent as possible. We have to make sure that we understand the tropical waters and then map it to the blue accounting system appropriately. So the three capabilities I've already talked about for this particular decision-making system is your blue accounting method itself, which talks about what assets exist, what are the services it provides, and what is the economic contribution. And then underwater domain awareness talks about what is happening underwater, your ecosystem, your ecological condition, what is happening now, and where it is happening, at what intensity, and the third capability is your modeling and simulation based marine spatial planning. So it gives you a predictive analysis, what is going to happen with the current state of affairs. So it helps you give you a come arrive at a scenario based approach. So you're accounting, you're observing, you're simulating, and then using those simulations, you're deciding, you're monitoring, and then updating the system accordingly. What UDA is going to be doing is making sure that all the relevant data, whatever is available and whatever gaps are there, it also highlights the gap, the data gap, so that the transparency is increased. So we arrive at an integrated marine intelligence, which will support your other capabilities. So what marine spatial planning in itself is going to be doing is that apart from your predictive analysis, it is also going to make sure that your trade-offs are visible. For example, if you take one particular sector, such as fisheries, you evaluate it against what are its different contributions, and then how that in that particular space, if an offshore energy sector is going to be developed, how is that going to impact all of these particular factors, and what are the conflict and the compatibility ratios that we can arrive at using the marine spatial planning tool. So blue accounting ultimately quantifies the value to some extent, and the UDA make sure that the value is current, the evidence is current, because it's going to be a near real time feeding system. And then your marine spatial planning will help you test alternatives. So with that background, I would like to start off with the basics of how we are taking up this accounting process. So we are going to be making sure that these five pillars that I have displayed here are going to be the backbone of the different methods that we are going to be taking up. The first is the natural capital. So your natural capital is basically your stock in the ocean. It could be biomass, it could be the habitat that it is providing, it is the biodiversity indices, and the ecosystem health itself in terms of coral bleaching, water quality, etc. And the second pillar is your ocean economy, which is basically what we have been calculating till now to some extent. For example, in India, at present, the value that we are considering as contributed through ocean-based industries is 4 to 5%. But grossly speaking, that seems to be like an underestimation, but we do not have the evidence to back it up or to support it or to contradict it. So in that scenario, what we have to do is we have to look at the other interconnected systems along with the ocean economy. So your third pillar is the ecosystem service. So this is basically the flow of the system, flow of your stock. What is actually being derived from your stock? And then the social and equity dimension. So your how it's going to affect your social the society, the livelihood, even the security-based issues, and also the advantages that you gain from these systems are not going to be equally distributed. There is going to be equity issues also based on the power and power of the stakeholder, etc. And the final backbone, the final pillar is going to be your governance and sustainability issues. So all the norms of sustainability and all the policies and vision that we are coming up, even the MAHASAGAR vision itself, all of these governance policies and visions, how are they mapping on to these existent systems? So the first four are what we have, and fifth is what we are going to be deciding. So In this interconnect, this is going to be our backbone of 5 pillars. And the approach that we are going to be taking up is the sectoral analysis strategy. So here we are going to be asking of picking up a few sectors. The sector could be the purely economic sector, or it could be a sector, an ecosystem itself, like a mangrove system or something, or a coral bleaching system, which has advantages, which could have value, which is adding value to the system. So we are going to be segregating it sectorally, and we are going to be asking a few questions. What activities use the marine space? Where and how intensely is the sector operating? What is its contribution? What are the pressures it's creating? Who is benefiting? Who is bearing the cost? And how is the sector regulated? So after asking these questions, what we are doing is we are starting narrow, and then we are trying to prove value of the system by collecting evidence, and then we are going to be standardizing it and then scaling it up. The method that and once we pick out a sector, we are going to be seeing a certain number of value generating factors, and a number of value degrading factors. For example, your value created will be your direct market value, your indirect values created, your avoided cost, your strategic cost, strategic value, your ecosystem services. And the value lost is going to be your environmental degradation, opportunity cost, restoration, and degradation cost. So your blue value is not revenue alone, but it is going to be the value of nature and the cost of environmental and social impact. So making sure that the ocean value of the development is visible. So starting off, I want to start to explain it better. Let's start with a case study. So what we did was we took Vadhavan Port and we analyzed how the biofouling management system that we are starting off in Vadhavan Port going to impact the environment around it, the ecosystem around it, what is the value getting generated, and what are the liabilities. So to start off, the purpose of a biofouling management system is to make sure that the ships so for those of you who do not know what biofouling is basically when the ship is transiting across the oceans, it kind of collects different algae and microorganisms and marine organisms in the hull and the underwater part of the ship. And these get hardwired into the skin of the ship. So making it very difficult for manual cleaning. So what happens is periodically you're supposed to clean it up. Otherwise, it is going to increase the inefficiency of the ship. It is going to increase your drag force, etc. So it's a periodic requirement, and when that is and not all ports have the facility to do it, and certain ports do set it up as a revenue generating system, and plus to make sure that the efficiency is increased. So the liabilities that were present because of biofouling are kind of addressed through a anti-fouling, the biofouling management system. So here, once we are setting that up, we are going to be asking a question. What conventional economics asks is that how much money does biofouling management save or generate? But what we are trying to ask is a broader question. What economic, ecological, strategic, and social value is created, and what losses or liabilities are avoided or generated because of biofouling management? And what is the best possible pathway, the technology, the social, the environmental pathway to execute that particular management? So what the results that we got was that as far as economic impact is concerned, about 4.5 lakh per hour rupees was getting expended because of persistent biofouling in ships per ship. So in that per hour, this was the economic liability that we are trying to overcome. And once the biofouling management system is in place, we are also going to be facing another set of liabilities, the pressures that that particular system is going to put in on our oceans, which is invasive aquatic species transfer, paint particles and biomass and turbidity changes, risk to fisheries and coastal ecosystem around that area, And also, if there are other power plants or anything else in the same zone, what the invasive species, how they are going to be impacting them, and how soon they are going to be impacting them, etc. And then what the bio accounting response is, what is the best possible way to make sure that the whole system is put into place. So we are measuring the environmental and economic benefits and liabilities, and we are also suggesting which is the best possible pathway to take it up. So the list of assets and liabilities have been listed down. So using which we are going to study how advantages this is going to be, and we are going to be using this in the equation that I had already showed before. So basically what we've done here is that we have made a comparison between what is the liability we have avoided using the system and what are the liabilities we have created. So this is going to be the critical point of how this particular business is going to be judged. Once we have all the factors in place, we are going to be putting this into our system. And we are not going to be arbitrarily subtracting or adding environmental and social impacts from the value generated, but wherever it is defensible to be monetized, we are going to be mentioning that. And the non-monetizable and strategic indicators are going to be reported separately in such a way that it is not invisible, but the key components are properly visible. The priorities are going to be set up as to see how we are going to make the final decision. So that was our Bardhavan case study. And we tried to do another interesting case study, which is to bring together three different sectors. So three representative sectors from economy, social, and environment perspective. So you have your ports, which represents your economic gains, your fisheries, which is important for your social, your livelihood needs, and then the mangroves, which represents your environmental factor. So we first what did first was we studied these three individually. We studied what are the different factors: the market value, the indirect cost, the indirect value, the avoided cost, strategic value, the ecosystem services, etc. Similarly, we studied the loss the same way. Now, after doing that, we try to see how, that we applied the blue accounting principles that we started off with to this three highly interconnected parts of the coastal economy, and try to connect the economic activity with the ocean assets, the ecosystem condition, and the benefits those assets provide to the society. So the objective here is to make the full development balance sheet visible. So this is only representative. The system is even more complex than this, but this is how we wanted to test the whole system. So for the ports, we generated the value, the environmental liability, the social liability, and we are trying to create a parallel accounting layer with the other sectors that we started off with. So for the fisheries also, we did a similar exercise. We saw what is the value created and what is the value lost. And for mangroves also, we did a similar exercise. So this is perhaps one of the most important part of this whole, because whole case study too, is because mangroves illustrate the difference between an ecosystem with a visible market price and as compared to something which is not visible, and one which has a large market value. It has a lot of ecosystem services value, but which is not properly visible. So bringing this into the forefront makes this exercise unique and challenging to some extent. Once we started off this, before I'm going, so the core challenge that we faced while doing the second case study is to account for the double counting problem. So, for example, 1 hectare of mangroves provide your nursery habitat, supports fish recruitment and increases fish availability, supports fish income and food security. But the accounting problem is that not there are the same stock and the service provider, there are intermediary outputs which gets accounted for double. For example, so to overcome that, what we are doing is to make sure that we represent the causal the chain of economic gains properly. For example, from the mangrove, you get the fish recruitment, and then you move on to fish catch, and then fish sales and fish income. So the potential double counting is there is a potential double counting if every step is monetized and summed. So what we are doing now is to make sure that we put a certain set of rules. For example, we define the physical asset first, and then we separate the stocks from the flows, and then identify the final value and attribute impacts spatially as well to see which community is impacted in that particular space, or which ecosystem is getting damaged in that particular space. So a spatial allocation is also done at this point, and then we maintain a double counting register. So what is a double counting register? Is something of this sort. So what we did was we picked up the value item, and then what is the asset associated with it, and we try to segregate into different types, whether it's a stock, whether it's a ecosystem services, whether it's an intermediate benefit, or whether it's a final output, or the opportunity cost or a restoration cost. And we try to define its relationship and make sure that we are counting it once and not repeating it. So what we are doing here finally is to make sure that we observe the system, we account for it, and then we model it. So in the modeling and simulation part, what we are trying to do is we are going to factor in the time and the space component into the equation, and making sure that a particular ecosystem, a particular stakeholder, or a particular ship is going to be defined in such a way for the time it is the time the period that an impact is the sector is working on it, or at what time of the year a particular work is being conducted, and for which season, which time, and which place, and how long. So these are different factors that we are going to factor it in the modeling and simulation part, and going to also come up with a scenario based analysis where if no, for example, you're in the Vadhavan biofouling example, if no intervention is applied, what is going to be the ocean value generated, the total ocean value in that particular sector? And if an intervention is applied, what is going to the total ocean value? And also, we are going to be comparing it with the different kinds of ways you are going to be doing the anti-fouling work. So in a way, you're going to get a delta ocean value, which can be used by the policymakers to arrive at a decision. So this particular the way the result is going to be displayed is in such a way that it benefits the stakeholders which we are going to be working with, the government, the investors, communities, and marine industries. So the value generated, even the externalities and the liabilities and assets that we are going to be listing, it's going to be a comprehensive data that is going to be generated for your stakeholders to make prudent decisions. So what we have done is we have created a common evidence base, and then we study the trade-offs, and which will give you a stronger legitimacy to for investors to invest, or for government to implement a certain policy, or to community to accept certain interventions by the government. So in this particular, what we are trying to achieve, and what we have partially achieved till now, is that we are trying to combine economic growth, ecological integrity, and social equity. And the question that we are asking no longer is how much does the ocean produce, but what ocean assets sustain their production, because we are defining the natural stock. And how do we keep them productive, equitable, and resilient? Through our study of blue accounting, through our study, through the modeling and simulation, we are going to be seeing how to keep them productive, equitable, and resilient. So from evidence, so we are going to move from a reactive system to a planned system to create an adaptive and climate resilient ocean governance. Thank you so much for the opportunity. I'll end my presentation here.